Help! My AC can't keep up. This is a common complaint many times throughout the year, and sometimes it's not what you would expect. Some symptoms can be that the AC runs and runs, doesn't shut off. It basically just runs and runs, doesn't get cool enough to cycle the equipment off. It doesn't get cool, or it doesn't seem to be getting cool enough. However, this discussion isn't going to talk about potential problems of the air conditioner that can cause this symptom. This discussion is more in the realm of capacity, what the AC is designed to do. Because a lot of times, design issues of the AC are inadequately diagnosed at the time of install. You may have just recently bought the house. There could be certain parameters that the previous homeowner did to suit their needs versus cost of what it was going to take to put the system in. This is basically in the realm of the importance of AC system design. The design is basically telling you what it's going to do performance-wise in order to keep you cool. Now, the trade-off is that, the more it's designed to cool, the more it's going to cost. So there's always that balance of, cost versus function. Now, one thing, a common argument that I've heard, when the air conditioning is deemed to be doing all it can do, I often get the comparison of commercial versus residential. You have to realize that a commercial application is completely different. For one, a commercial application, you could have cooling systems, upwards of 25 tons or more. Whereas a residence will typically, the largest system made for a residential type application is 5 tons. Now, there are some variances, and it depends on what type of residence we're talking about, but the majority, the maximum is 5 ton. Now, another difference is that commercial can be staged, which basically means that the system will, as the load increases, the system will increase the air conditioning required to cool the structure. So comparing a commercial, like if you work in an office building or something along those lines, it's not a fair comparison, and one thing you got to realize is the commercial load is completely different from a residential load because of varying loads, as to what's in the building. Is it a building with a lot of people? Is it a building with a lot of loads, such as like in a restaurant where they've got cooking equipment? You got to realize that all these loads are determined beforehand when the system is put in. The other comparison is the old residence versus new residence. You got to realize there's differences in homes. There's differences in sizing potentially, difference in windows, differences in shading. The list goes on and on. The analogy could be used like, as an example. Your last car could go 300 miles on a tank of gas, but your new one could only go 250 miles. Well, it's a design limitation, Maybe the new one doesn't get as good as gas mileage as the old one. Maybe the tank is smaller. All these limitations go into pretty much anything we're faced with. But many times, when it comes to air conditioning, you got to take into account what is air conditioning? What is it designed to do? What is its design limitations? So that's what we're going to discuss in this little clip. So next up, what is air conditioning? Air conditioning is measured in tons. So the next question is, what is a ton of air conditioning? The connection between a ton of harvested ice and a ton of the modern era air conditioner capacity involves the amount of heat energy required to melt 1 ton of ice in a 24-hour period. which is 286,000 British thermal units, or 12,000 BTUs per hour. 1 ton of air conditioning. So you fully understand that there's a limit. This graph basically illustrates that the hotter it gets outside, the less capacity you're going to have in your air conditioner. Now, you got to realize that design characteristics come into this. And basically, I use this chart as an illustration because it shows both refrigerants currently in use today. Now, there have been drop-in refrigerants that have come out that really weren't deemed drop-in refrigerants for high-temp air conditioning application. A lot of these drop-in refrigerants are for refrigeration and things that were refrigerants that were even worse than R22. So you got to realize that, if you went with a drop-in refrigerant, in all reality, the capacity loss would be worse than what is shown on this graph with R22 Freon and R410A. It would be even worse. One thing to note is that, if you, at 95 degrees, which is basically the design characteristic for air conditioning, 95 with a 75 degree indoor, at least for my area. Now, there's some fluctuations, depending on the area, which you live. But for my area, it's designed as 95 degree outside, 75 degree inside. Now, you can fluctuate that a little bit, and you could design it for a 30 degree drop, which would be 95, 65. Just realize that, when you do those things, it has to be staged appropriately. Otherwise, you're going to have more trouble than you can shake a stick at when it comes to residential type applications. You don't want to, have overcapacity because you'll have mold and mildew issues popping up. And that's a whole nother discussion. But just to give you an example on this high temperature, you got to realize that this high temperature is the ambient outdoor temperature. That's what OAT stands for, outdoor ambient temperature. It's the entering air temperature that's entering into your condenser. Now, once you hit 105 degrees outdoors, if you look at the chart, you can see that you're at capacity of 0.95, which means you've now lost 5% capacity at 105 degree outdoor ambient. Now, if there's a extensive heat wave, that's typically when you're going to notice it. If the heat wave lasts a week, 2 weeks, 3 weeks, that's typically when you're going to notice. You're going to say, man, this air conditioner just ain't working right. Even more so if you're putting additional loads on the system than what it was designed to handle. For example, you have a house party, you have guests over. You got to realize you're adding loads to the system that weren't accounted for. Other loads could be excessive incandescent lighting, halogen lighting, anything that produces heat can basically add detrimental effects. The hotter the temperature is outdoors, the less heat transfer that can occur. You got to realize that heat moves from hot to cool much easier than hot to hot. The less heat transfer you have, the less your air conditioner is going to perform. That's basically the name of the game. And so what I've done is I've taken some of these statistics off of various equipment. This is basically a 5-ton 14 SEER condenser. I'm going to flip to this other chart. It's kind of better because I've got it. I've got things highlighted. And typically, a 5-ton air conditioner, typically you're gonna shoot for 2,000 CFM on the indoor blower. That's typically the most common. Now, you get into variable systems and you can vary it out, and just realize that you're going to affect the performance one way or the other. One thing to note is that, at 75 degrees, if you've got a 72 degree indoor entering wet bulb, and this is a wet bulb temperature, so, typically a wet bulb temperature is typically less than what your dry bulb temperature is. So, your capacity at this entering wet bulb is 69.54. Now, you basically divide that by 12 to find the tonnage. So you're basically, at that temperature, it's running at almost 6 tons of capacity. Now, it wasn't designed for that temperature, so, but this is just to show you that how much potential, how much the system will vary based on the condenser entering air temperature. Now, one thing to realize is that 75 degrees outdoor ambient, you're not going to run the AC all that much. Now, if you've got a heavy load in there, it's going to be much easier for it to drop the temperature down because you've got 6 tons of capacity at this outdoor ambient temp. Now, if you flip it over to 95 outdoor ambient temp, you'll see that capacity at 72 wet bulb is slightly above 5 ton. And that's basically what it was designed for. Now if you've got an entering wet bulb of 63, you'll notice that it's not even a 5 ton. It's probably about a 4.5 ton, maybe a little bit less than a 4.5 ton at those temperatures. Now if you drop out further, you'll see that everything drops because the outdoor ambient temp has jumped to 105. It's not designed for 105, so capacity is going to take a hit. So with that said, we'll move on to a different manufacturer, different model. These are 4 and 5 ton system capacities at different outdoor ambient temperatures. It's basically the same thing. There is no difference. It doesn't matter what brand you use, it's the same. Sure, there may be some differences in total BTU output, what it can handle, but for the most part, it's pretty much the same. I mean, there's really no difference. This is a 4 ton, and you can see that at 95 degrees, it's not going to even hit 4 ton. It's 45,000, which is just a shade bit less than a 4 ton. Now, additionally, you also have to realize is that these conditions are at 80 degrees indoor dry bulb. This is a typo. It should be IDB, indoor dry bulb. 67 degrees Fahrenheit indoor wet bulb at 1400 CFM. The design, which is 95 degree outdoor dry bulb, 75 degree indoor dry bulb, 63 indoor wet bulb. At 95 degrees, you can see that, outdoor ambient temp, the system is going to run as 43,400 BTU, which is really about a 3.5 ton. But yet it's rated as a 4 ton. So, this all comes into system design. This all comes into design, but the thing you got to realize is that, even with all of this and people putting in, bigger systems, it's still, where most systems put in are oversized. And a lot of this is just due to ignorance, not knowing any better. This system over here on this side is based on a 5 ton, 14 SEER 5 ton. It's basically the same thing. The difference is that you take 12 into that 57, and it's 3,000 BTU shy of being a complete 5 ton. 75 degree indoor, 95 degree outdoor with a 63 degree indoor wet bulb. It's going to run as a 55,000 BTU air conditioner, which isn't quite 5 ton. It's about 5,000 BTU shy of being a 5 ton air conditioner. Now, there's more that goes into it than just that alone. You've got to realize that a system is only going to perform based on what it's designed to do. If you live in the Katy, Cypress, Richmond, Texas areas and some surrounding areas, you can give me a call at 832-475-6895. For Austin Air Company, this is Ray Austin. We hope you have a comfortable day. Thank you for watching.